Okay, so today and on Monday and Wednesday, we'll be looking at Putnam's way of developing the theory of reference, and then we'll go on to Evans. So the basic question that Putnam is using to frame the discussion in meaning and reference is, do our psychological states fix the references of our terms? And as I said in the very first lecture we had, that's the natural way to think about language, that it's what's in your mind, it's what's in your head, that is breathing life into the signs of the language. It's what's in your head that is making the whole thing go, that is making the language, making that system of signs into a representational system in the first place. So if that's your head, then the question is what's in your head fixing reference? And if you think of it in terms of sense or descriptions or clusters of descriptions, then it seems like, well, the sense or the cluster of descriptions, that's something that you grasp with your mind. That's something that you know about. So the general question is, just for people who came into a second, but the general question is, do our psychological states fix the references of our terms? And if what's in your head is a sense or a description fixing the reference, well, it looks like that description, that's something you know about, that's something in your mind. And that thing there, the intermediary that is fixing the reference of the term, you do grasp that. So that's going to be fixing the reference. So it looks like on the classic Frege-Searle kind of picture, the answer to this should be yes. Your psychological state is fixing the reference of your term. It's a little bit different if you have a causal theory where you do without the sense or description, and you just have a causal chain. Because the causal chain between you and your surroundings, that's not itself, on the face of it, something interior to your mind. Right? The causal chain is something about the relation between your mind and the environment. So on a causal chain kind of picture of reference, it looks like the answer to this question should be no. It is not your psychological state that's fixing the reference of your term. There's a sense in which we're not really in charge of the way our language works. Rather, it's the causal connections between us and the environment that are shaping what we say and think. It's not something that we just lay down. There's nothing conventional about the existence of a causal chain. It's not a convention of human language. That's just the way the thing works. It's not up to us. So that's the kind of framing question in Putnam's discussion. Is what's interior to your head, is your psychological state, what's fixing the references of your terms? And he's got this let's just think about the characterization of what a psychological state is. And he's got this famous example of twin earth that we'll spend most time on today. So what's your psychological state? Your psychological state is something that's independent of your relations to your surroundings. If for anyone who's done Descartes, this goes right back to the idea, well, it might all be a dream. It might all be hallucinations. I might just be sitting by the fire thinking I'm giving a lecture. I might be fast asleep at home thinking I've made it to the lecture on time. You might be just fast asleep at home thinking that you made it to the lecture on time. But your internal psychological state could be just the same. Even if you were a brain in a vat, your internal psychological state could be just the same. So your surroundings cause you to have different psychological states, but what the traits are intrinsically, that has to do only with you. One way to think of this is in terms of your knowledge of your own psychological states. I mean, the way Descartes put it, I mean, I guess most of you know Descartes, I've come across Descartes' meditations, I think therefore I am and all that stuff at some point, dear old Descartes. Well, the way he was thinking of it was, my knowledge of the physical world, that might all be a dream, that might not really be happening, but I can survey the contents of my own mind. I can just look inside my own mind and see there what is going on. So you have this domain of your own psychological states over which you really have this special authority. And whether or not you're dreaming, whether or not there's anything out there, you know what's going on in your own mind. And that's not just your own mind at the moment. I mean, presumably that would apply to your memory of your mental states yesterday. Maybe what was going on yesterday was all a dream, but you still know what was going on in your mind yesterday. If your memory is working, then you still know what was going on inside your own mind, even if independently of what your relations were to your surroundings at any point. So Putnam's twin earth example is meant to challenge this kind of idea. So the twin earth example is, well, imagine that far, far away in a distant galaxy, there is a solar system just like this one, an Earth just like this one, a US, a California, a Berkeley just like this one. And there is a counterpart of Wheeler Hall, an lecture room just like this one, full of bright, eager faces, thirsting for knowledge, just like this one. And as you can see, twin Earth is very like Earth. I mean, really, it's very hard to tell them apart. Except for one crucial detail, it's exactly like Earth. I mean, if you want to take a moment, you should check it out. I mean, can you see any difference? No, they really are very, very similar. Yes? You're reading the caption. But brilliant. Okay, well done. Okay. So you can, with that small detail, let's say you see they're very, very similar. So you have got a double on twin Earth. Your double right at the moment is molecule for molecule identical to you. You raise your hand, your double raises their hand. You feel thirsty, your double feels thirsty. Okay? Molecule for molecule, they're exactly the same, with some crucial differences. Now, suppose that we swapped you in and out for your double. Would you notice? Suppose that right at the moment we can zap you into the seat of your double. You can see what I mean? We swap you out. Would you even notice what was going on? Okay. Is your psychological state the same as that of your double? Well, sure it is, right? What would the difference be? If you were being swapped in and out, you wouldn't tell any difference. Nobody can tell any difference. If you've got a headache, your double's got a headache. If you're feeling puzzled, your double's feeling suspicious. your double's feeling suspicious. Yes? Okay. So that's it for twin Earth. We'll develop the point a little bit further so on, in a moment. But the key point is there's that notion of psychological state where even though you and your twin are in quite different places, surrounded by quite different people and objects, what's going on with the two of you internally is exactly the same. What's going on in your mind is exactly the same. That's the first key point. Your mind and that of your twin, there's no difference between them. Are you all happy with that? Comfortable with that? Okay. Well, here is the one key difference between Earth and twin Earth. On twin Earth, there is a liquid that fills the lakes and rivers that falls from the sky. It looks just like water, but it's not water. It's not H2O. It's got a very long, complicated formula, which, for technical reasons, I wouldn't go into exactly what it is, but we abbreviate it as X, Y, Z. Okay? So at normal temperatures and pressures, H2O and XYZ are indistinguishable. You only really see the difference between them showing up when you heat them to something like the temperature of the sun or freeze them to absolute zero. You don't really notice any difference regularly. All right with that? So although you and your twin are molecule for molecule identical, the liquid circulating through you is different, but that difference doesn't show up in the chemical behaviour of the thing. So you're still psychologically identical, you and your twin. Yep. It does make you not molecule for molecule identical, but what I'm suggesting is that difference doesn't show up at normal temperatures and pressures in the behaviour of the substance. So you're still going to be psychologically identical. You see what I mean? Yep. Yes? No, see, at normal temperatures and pressures, XYZ is just the same as H2O. The chemical reactions are just the same at normal temperatures and pressures. I mean, it would take you too far into advanced chemistry to really explain how this works. Yeah. If you really badger me about this, then we can make it so that in twin Earth, there really is some H2O, but it's confined. Actually, it's too complicated. Yeah, if we drained you or me of water, of H2O, and pumped in a whole bunch of XYZ, you wouldn't notice any difference. Yeah, nobody would notice any difference. At normal temperature, unless we heated you to the temperature of the sun. You see what I mean? I mean, I know you guys are not chemistry majors, so stop me if this is getting too technical. You see the scenario? Okay. So if you look at a high school on twin Earth, and you're being taught about the evaporation condensation precipitation cycle, it looks just like the one here, right? This is very, very similar to the kind of diagram high school students on Earth get. But this is what they get on twin Earth. So the water was working in the environment. I mean, the XYZ is working in the environment in just the way that the H2O does here. You want to take a moment to digest that? Okay. So here's Putnam. Actually, here you're saying it. XYZ is indistinguishable from water at normal temperatures and pressures, so you don't have to take my word for it. The oceans and lakes and seas of twin Earth contain XYZ and not water. It rains XYZ in twin Earth and not water, and so on. So if you take a typical, I mean, this is an actual shot of twin Earth. You can see, you can see that it looks very, very similar to a rainstorm over water on our Earth. You see the similarity? I mean, you can really tell the difference with the naked eye. Okay, so what's going on is that we have a substance which we assume has some particular underlying structure, but we might not know what it is. But we say it behaves in these ways. It participates in the, and you find it in all the rivers and lakes and so on. You see that it's evaporating from the seas and forming into clouds and then blown about and precipitated again. You see it behaving in all those ways. You see it dissolve stuff that plants need to live, and you and I needed to live. So there are all these behaviours of the substance, and you assume that there's some kind of underlying molecular or whatever structure that the thing has that is explaining that behaviour of the substance. Yep. I could elaborate on that idea a little bit, but is that plain enough just the way I've said it? So it's not plain enough. It is plain, okay. Oh. Okay, come back to it. We can see what happens, come back and tell me why you don't believe it. Okay. So on Earth, what we find out is that the structure underlying these behaviours of the substance is none other than H2O. And at that point, it's a discovery that water is H2O. It's a discovery that gold is the stuff of atomic number 79. These are all chemical discoveries. The names of the substances were known for centuries before the actual underlying structure was found. But when you say water is H2O, that is our old friend in informative identity. Right? You're saying it's one and the same stuff, water into H2O. You found that out. It wasn't a priori. It wasn't just something you made up. It wasn't just something you stipulated or laid down. You found that out. So on Earth, we were using the word water for centuries before we knew anything about molecular composition. So when you learn that water is H2O, that's a discovery. You're finding out what the word water stood for all along. Yeah, you're finding out what that substance really is. So in twin Earth, what goes on is that they have a substance with very similar behaviours to our substance. So the S1, S2, S3, S4 here are all just exactly the same. And they assume there's some underlying molecular structure here. But when they find out that the molecular composition is XYZ, they say their informative identity is water is XYZ. But then they say, well, that's how they put it. And when they say that, that's a discovery. They're finding out what the word stood for all along. They've not just stipulated this. They're finding out an empirical fact about their surroundings that they're expressing by saying water is XYZ. Okay? So you and your twin, the point I've got to so far, you and your twin have exactly the same psychological states. But you, when that moment of revelation comes, will say, water is H2O. Your twin will say, water is XYZ. Yep. Okay. Here's Putnam's way of expounding the idea. For every world, one way you could understand the meaning of water is to say, well, if you put it in terms of possible worlds, then take any possible world. What is the word water? What does our word water refer to relative to some other possible world? Suppose you said, had there been water on the moon, there would have been lots of life on the moon. What substance are you talking about then in that counterfactual situation? Are you talking about H2O, XYZ, something else? H2O, yeah, I mean, that's my hunch. That whatever counterfactual you express using water, you're talking about H2O. Yeah? So one way, this is a little bit like this debate we were having about the Strangler. One way you could hear the word water is as standing for a kind of role that a thing can play. So you could say, well, there's the stuff that plays the watery role on Earth, and the stuff that plays the watery role in twin Earth. Yeah? So you could say, here is the local water about the stuff in twin Earth. And you could say, well, had there been water on the moon, it would actually have been XYZ, because the moon doesn't contain enough hydrogen and oxygen to make regular water, I suppose. You see what I mean? But the way you guys have just expounded it, and I actually agree, that's not how we operate in practice. We think something like this. It's not that whatever world you're in, water is the stuff that is chemically similar to the stuff that's playing the watery role. So the idea expressed here is, you point to the stuff that's filling the rivers and lakes and falling from the skies, and you say, I'll call that, anything that fills that role, water. Yeah? And anything that's chemically similar to it is water. And that chemically similar notion is going to be something that science explains for you, ultimately when it gets to down to the nitty-gritty and as well. We're talking about molecules here. So this way of putting it would be to say water is like a flexible designator. Yes, it's like a description specifying a role. Whatever stuff plays the watery role. But you guys are saying that it's something different is going on. What you're saying is, for every world, we were talking about some counterfactual situation, when you say, had there been water on the moon, what you're saying is, we're talking about stuff that is chemically similar to whatever it is in the actual world that plays the watery role. Yeah, so this is one of these descriptions of an actual unit. So is this, reading it this way, is this rigid or flexible? Very good. Any votes for flexible? Okay. Because in order to find out what substance it's referring to in any world, you have to keep tracking back to the actual world and looking at what's playing the watery role in the actual world. So that's really kind of intuitive. Suppose you ask, is it necessary that water is the stuff that fills the rivers and lakes, falls from the sky, quenches thirst, and so on? Is that necessary? Yes? So in every possible world, that's true? Yes, that's very good actually. A priori, yeah, but is it necessary? That's to say, look at meditate in all those worlds, right? There's a lot of them. In every single world, is it water that is filling the watery role? Yeah? Right? Yes. It's what? Yeah. I think you're right about the a priori. But if you think, well, the reference is being specified by whatever it is in the actual world that fills that role. So there could be another possible world. I mean, there is another possible world in which something else fills that role. Yeah. And after all, it could have been that all the H2O got drained out of the rivers and lakes here. Could have been. And that some benevolent aliens filled up the planet with XYZ, which would do just as well. Had that happened, it would have been something else that was filling the watery role. That was so it wouldn't be, in that case, it wouldn't be water that filled the rivers and lakes. Watch me very closely here. So this is necessary. This is not necessary. That's all right. If I'm explaining this correctly, it should really be pretty easy. Is this all right? Yeah. It's not necessary that. Because there could be ringers for water. There could be stuff that looked like water but wasn't water, right? And I mean, I began by explaining this in a way that's kind of chemically very implausible. But really, for most kind of substances, this is just a general point. There could be ringers, there could be lookalikes, and most things are like that. Wood is like that. There could be a lookalike for wood. Most animal species are like that. There could be lookalikes for tigers. Most chemical substances are like that. There could be lookalikes for most chemical substances. Yeah. So if you can have lookalikes, that's to say, there could be something else filling that role. So it's not necessary that whatever the role is of the chemical or animal or whatever, it's not necessary that that animal is filling that role. On the other hand, is it necessary that water is H2O? Very good class, yeah, right. It is, I mean, on the story I'm telling anyhow, it is necessary that water is H2O. Why is that? Well, because in any possible world which you want to find out what water stands for in this world, you just keep having to track back to the actual world and find out what the term stands for, what substance the term stands for in the actual world. And in the actual world, what we happen to know is that it's H2O. Yeah? How is that a priori? I don't think I've addressed that yet. I haven't addressed that yet. I do think it's a priori. Oh yes, I said in comment, in reply to his question that it was a priori. Give me just a second. Right. Because I really need some explanation. Okay. And the intuitive idea here is that what makes H2O, what makes water the stuff it is the essence of water is whatever explains its characteristic behavior. If you ask what makes it say that the atomic number of an element is essential to it, is that the atomic number of the element explains why the element behaves the way it does. So the essence of a thing is whatever makes it behave in just the way it does. So it's because all the chemical substances have their particular atomic or molecular constitutions. That's what makes them behave the way they do. That's what makes them have the temperatures of boiling or freezing, for example, that they do. So in general, the essence is what makes a chemical substance the chemical substance it is. It doesn't make sense to say I could have the same chemical substance but a different molecular composition or a different atomic number. So although, looking at this, you guys might say, look, water might be a rigid designator. Well, what about the H2O? Isn't that a description? Yes? I mean, it's describing, it has, whatever it is, 2 hydrogen atoms to 1 oxygen atom. Yeah? It's nonetheless a description that's really basic because it's specifying the essence of the substance. It's specifying a characteristic the substance couldn't but have. So it is actually rigid. In any world in which you have H2O, it's the same substance. H2O is not a flexible designator. So we think of it like that, H2O is the essence of water, but this last question, is it a priori that water fills the rivers and lakes, falls from the sky, quenches thirst and so on? How about that? It's not a priori. You said a minute ago, was it a priori? I'm sorry, I'm not trying to catch you out. I'm just surprised. Okay, yeah.
Are you talking about water as NYD or are you talking about water as H2O?
I'm just talking about what on earth we mean when we say water. What we mean when in regular English we say water. That's very good. You do need experience to understand what the term is. Yeah, that's right. The way you explain to someone what water is by showing them something. Yeah. But in general, remember, with an a priori proof, you often need some experience.